Hello everybody. So we're still talking about the calculate option in Aspen Plus, and in this video we will do one more exercise. So previously we did the exercise of calculating the solvent flow rate according to or based on the feed flow rate. Um, uh, Using the calculator option, and today I want to do one more thing, which is kind of help us learn more about the calculate block in Aspen Plus. So just to revise quickly the process that we are talking about, we have here a solvent that is going in an absorber to absorb ammonia from air, and this water is fed to the stripper to get rid of the ammonia and produce almost pure water that we can recycle and use here. So ideally, the amount of water that I feed here should be equal to the amount of water that I get out from here. But this doesn't happen because we have some losses in the system. So there is some water that's lost with the pure gas here, and some water is lost with the product ammonia here. So what I need to do now is to see how I can or to calculate the amount of water or the total amount of water that has been lost in the two columns, which is the sum of the amount of water here and the amount of water here. So this is the first thing. And to calculate the percent of the losses in water that I have in my system. So which is the sum that I just or that I want to calculate divided by the total solvent or flow rate that I have here. So this sounds like easy, but there might be some challenges that we are going to talk about. So we'll go to manipulators and create a new calculator, and I'm call it lost water. And this lost water is I'm going to define some variables now. So I need to define the solvent flow rate, which is the feed solvent, or let's name it feed solvent flow rate, and we want to calculate the water from absorber and the water from stripper, and the total water, which is going to be calculated, and the percent loss, which is the amount of water lost divided by the total amount of water that I used. These two will be exported, and the three variables will be imported from the inputs or from the file that or the simulation results. So now let's go one by one. This is a stream. This is going to be mole flow because it's a component mole flow of the feed, which is the solvent to absorber, and this is the water in this stream. And I did it like this despite having pure water as a feed, because I know that this I want to make it like a universal thing, that it doesn't matter how much impurities I have in the feed, it's going to be calculated based on the amount of water only. The water from absorber is going to be the mole flow of the stream, which is the pure gas, and the component is water as well. The third one, which is water from a stripper, is going to be stream, and this is going to be mole flow for the stream, which is the product ammonia, and this is water as well. So now I'm almost done with defining all the inputs, and this is gonna be kind of challenging now, and I'm gonna keep it for just few minutes until I get the calculations done. I'm gonna go for Excel because it's easier for me, and I believe for all the users. So we're gonna go here, and again we'll make it side by side, and I have now how many variables. I have the total feed solvent, I have the water from absorber, water from stripper, and the total water loss, and the percent water loss. So these are the three inputs, and this is the two outputs that I want. So I'm gonna I'm gonna put this as the feed solver. I'm gonna make this as the water from absorber. This is the water from stripper. This is the total water lost, and this is the percent water lost, or percent loss in water. These three are gonna be imported from the file, and this is gonna be this. I'm sorry, this is gonna be water from absorber plus water from stripper, and this is gonna be the total water loss divided by the total feed solvent. So this is all what I need to do. I'm gonna go back here, and now everything is available here. And now I will face one problem here, which is that I need to define these variables. If you open the Excel file, I have here this as mole flow of a stream or whatever, but this and this are empty because I haven't defined anything here. And the reason I didn't do that, because there is no place for them. So previously I was calculating the flow rate of the solvent, which I know that there is a solvent stream that's going into the absorber, and that's why I know that the number should go in this stream. But in my case, I'm calculating just a number, and I don't have any place where this number should go. There is like no stream that I'm gonna like put to combine the amount of water that I did. And even if I have this stream, I don't have a stream to have the percent losses. So this is not kind of logical, or a thing that or a parameter that can be attributed to a stream. So for this thing, I have options like block, stream, utility, and property, parameter, and reactions, and I tried like everything here. I didn't find anything here. So I tried to think of something like a tweak so that I can get it to work. I'm kind of tricky, but just to get the numbers, I just need some numbers. I don't want to like get something out more than that. So what I suggested is to create any like random stream here. I'm gonna call it water loss, and this stream is where I'm gonna put my outputs in. So I'm just demonstrating just for you to understand what I'm talking about. So for the total water flow, I'm gonna make it a stream variable, and this is gonna be mole flow for the stream which is called water loss, and this is gonna be water. So by doing this, I'm telling the software that the sum of the two streams or the water in the two streams coming from the absorber and stripper is gonna be equal to the water flow rate in the stream, which is called water loss. So when I go to the main flow sheet, if I run the simulation, I should expect to see this flow rate of water here should be equal to the sum of water here and water here. Again, this is just something to get the numbers, or find the place for the numbers to be put into. Again, for maybe the second is kind of more challenging, because this is a flow rate, so I know that this can be defined as a flow rate, but this is percentage. So I thought of something that might be kind of working. So I said that this is gonna be stream variable, and this stream variable is gonna be the water loss. And this variable is going to be just, I need a fraction, because this is going to be fraction between 0 and 1. So I thought of you putting this as the vapor fraction, and instead of as a parameter that has the exact same range of values. So by doing this, again, this stream that I created has nothing to do with the flow sheet. It's just a place to put the outputs of the calculator. So this is exactly the reason of creating this stream. So now the last thing that I want to do now is to run the simulation. But if you click next, you would see that the input is incomplete, because this created stream has not been defined yet. So I have to define this stream. So I'm gonna put any flow rate, just 1 kilomoles per hour of water, and I know this is gonna be overwritten by the number that's gonna be produced from the calculator. And the temperature, I can put any temperature, 25 Celsius. But the kind of thing that you need to think about is that if you define the stream by temperature and pressure, then the degrees of freedom and flow rate, of course, but the degrees of freedom will be equal to 0 now. So the vapor fraction would be calculated according to the input variables of values of temperature and pressure, and they cannot be overwritten because they are inputs that are given to the simulation or to the software. So the software cannot put temperature and pressure and vapor fraction, because the vapor fraction is dependent on the temperature and pressure. So if you put it like this, then you find that the vapor fraction will be calculated based on the temperature and pressure and will not be updated even if the number that you put is different from the number in the calculator or coming out of the calculator. So the easier way is to go for a vapor fraction, which is an input. So I'm gonna put the vapor fraction here as like 0.5, just any number. And by doing this, the software can update this number because this is an input and it's not going to contradict with other inputs that you put, like in case of defining the pressure and temperature. So by doing this, you should be good to go, and the calculator should work. I'm going to put this side by side with the calculator here, and I'm gonna run the simulation and see what the outputs that we're gonna get out of the software. So now it got the feed flow rate that was calculated from the first calculator, and this is the nice thing. I have now two calculators in my flow sheet. One that's calculating the solvent to absorber from the feed gas, and the other is calculating the lost water and the percent of water lost based on the feed flow rate, which is kind of nice thing. So now you can know that the water that's lost from absorber is 2.98 kilomoles per hour, 36 from the absorber, 36.4 almost, and the total water lost is 39.37, and the percent water lost is 3.2%. Again, if you kind of or want to check it just for the sake of making sure that everything is nice or fine and there is no problem, you can see the results of this stream, and this number is exactly the same number, 0.032809, which is the exact same number, and the flow rate is 39.37, which is this number. So it's working fine, it's working nicely. And again, as I told you before, you don't need to go to the Excel file or to check the stream, because the Excel option in the calculator displays all the outputs easily, and you can see the outputs highlighted in blue. So it's kind of telling you that this is the output. So even if you put the stream and don't even see what you have inside this stream, you can easily know the outputs. And as I told you, this stream has nothing to do with the simulation or the flow sheet. It's just a place to put the numbers in. So I think this is a good trick that you can use to calculate parameters or calculate variables from the results of the simulation that do not have place to be stored in. So I hope it helps, and I'll see you in the next video, inshallah. Goodbye.